Hi viewers, welcome to LMS Solution. Today we are going to see about speed control of BLDC motor using H Infinity controller. In this video, we are going to see about how to implement H Infinity controller for speed control of BLDC motor. Here you can see that this is a simulation model of the BLDC motor control. It consists of controlled voltage source and then voltage source inverter, BLDC motor, and then we have that gate generation based upon Hall sensor, and then these are the measurement of BLDC motor like stator current, stator back EMF, rotor speed, electromagnetic torque. In order to apply Infinity controller, first we need to find out the transfer function model of this BLDC motor. Here we know about that transfer function module in the simulation. We need to find out that transfer function of the BLDC motors. We need to provide that when we need to collect the input and output data. Here you can see that I'm going to provide input for that controlled voltage source, and I'm going to collect the data here, and then here we are going to control the speed of the BLDC motor. That means output speed of the BLDC motor going to act as the output of that BLDC motor here in order to get the transfer function. So here I'm going to collect that the speed of the BLDC. Here I'm going to simulate the model. For example, I'm going to simulate the model for 2 seconds. Initially, I'm going to make the voltage level for that control voltage source is equal to 300, and then the maximum voltage I'm going to fix as 500. At the time of 1 second, the voltage of control voltage source change from 300 to 500. So I'm going to apply and I'm going to change the time. I'm going to simulate the model. Simulation of this model, we will get the result here. This is the result of the speed of the BLDC. That bundle will be available in the workspace input and output. So next we need to identify the transfer function of that BLDC motor. Further, we would just type it and it will be open this window. This option is to identify the any system in the transfer function model. So I'm going to import the data. Here you can change time domain data, and then you can type the input data. Input data is in, output data is out, and then the starting time is 0. The sample time I'm going to consider as 0. You have to find the sample time. Here the total number of sample is 40,000. Here the total time you are taken is 2 seconds divided by 40,000. Sample time is 5 u per minus 5. You have to fix the sample time here, and then click more option, and also here you can provide the data in and out. Next you have to click import. The data will be imported here. So next time you have to use that mean. I'm going to remove the means, right? I'm going to use this one. After that, I'm going to estimate the transfer function. For estimating a transfer function, I'm going to click the transfer function model here, and then here you need to provide number of poles and number of zeros, and then I'm going to use discrete concept. Here I'm going to default. I'm going to use number of poles equal to n, right? Zeros equal to, so number of poles equal to 2, number of zeros equal to 1. And I'm going to estimate the transfer function. It automatically estimates the transfer function. Estimation process completed. Just close this one and close this, and then you can check the result model output. When you click model output, here you can see that the blue color line identified data, and then the fitness values are 93.19%. Now I'm going to click this one. Here we will see that the transfer function on this collected, that means for collected data of the BLDC motor. This transfer function in terms of discrete form, we can get the transfer function is an S domain also. Further, you can click once again transfer function model, and then use continuous function and estimate the model. That means you have to find out the transfer function model with the number of poles equal to 2, number of zeros equal to 1. It will be finding the transfer function values. So we will wait up to completion of this process. After completion, here you will see that now estimation process completed. Now close, and then here you will get the transfer function. This is the final transfer function of that model. This transfer function already we collect the data for different trial. Already we did that things. Here this is the transfer function for that particular model for the BLDC motor we collected. And here you need to create the plant. In order to create the plant, you have to provide some disturbance input. These are the transfer function and values used for creating that disturbance. Based upon actual plant, that when transfer functionality motor and the disturbance input and control input, you have to create the plant by using this command. After that, here we are going to apply H infinity controller synthesis by using this command. This command is for generating the controller for the a particular plant. After executing this one, you will get the plant here in the, it will be stored in the name in K. After that, I'm going to open that controller in this state space model, and then it will be converted into transfer function model. So this is used to for seeing that the state space model of that developed controller of H infinity control. This is a transfer function model of the H infinity controller for the particular transfer. Here I'm going to simulate this one. So finally, we will get the actual transfer function. That means so this is a transfer function for the H infinity controller. This can be used in the Simulink model to control the speed of the BLDC motor. Just you would note down this transfer function here. Here I'm going to open this one. Here you can see that the transfer function of that H infinity controller is included in the transfer function model. So provide the data here. That means numerator data and denominator data in this transfer function block. So this will be going to be act as a infinity controller for the particular system, particular BLDC motor control. Here you can see that here we are measuring the actual speed and compared with the reference speed, and then process via such infinity controller. That infinity controller provide the control voltage to the this voltage source. So it going to be control the speed of the BLDC. In this we are going to design. This is the way of designing H infinity controller in the MATLAB. Next, I'm going to simulate this model, and then we will check the results. So this is the input voltage, variation of input voltage with respect to change in reference speed command. And then this is, I will explain the detail clearly. Here you can see that this is change in variation of this input variation depends upon the reference speed command. Initially, the set speed is 3000 RPM. The voltage of the input side, DC side is around 480 volt. Here you can see that the speed of the BLDC motor is settled at 4 seconds without any overshoot. After 1 second, the set speed or reference speed is changed from 3000 RPM to 2000 RPM. Here you can see that the speed of the BLDC motor is settled at 1.3 seconds after change from the 1 second. During the change of reference speed command, the voltage of the input side is changed from 480 volt to 320 volt. This is a variation of electromagnetic turn during changing of speed from 3000 RPM to 2000 RPM. And then here you can see that the variation of stator current and electromagnetic force, and then electromotive force, and then this is line to line voltage of the BLDC motor. Here you can see that after designing a touch infinity controller, we are getting the smooth response. That means controller easily track the reference speed command very quickly without any overshoot and under. This is working of H infinity controller for speed controller. Thank you for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming video. Thank you so much.